Okay, so let's start with today's Leetcode daily challenge, guys. And this is the 10th day of our doing this. And the question is letter tile possibilities. Fine. You have n tiles where each tile has one letter, tiles I printed on it. Fine. Return the number of possible non empty sequences of letter you can make using the letters printed on tiles. So what can be the possible sequences with A, B, three tiles? A alone, B alone, A, B, B, A, B, A, B, A. Fine. I mean, that's a standard backtracking question, right? Obviously, where we like need to explore all the possibilities, we go for backtracking. So what we can do here is see if with the backtracking solution, what we can do here is initially, let's just count the frequency of all the elements. Like how many number of A are there? Two, how many number of Z are there? Like in A, B, two A's are there and one B is there and rest of them are zero. Right, 26 characters we will say and rest of them are zero. So we will start now exploring them. We can also use the DFS here. Yeah, but let's go with backtracking because that's basically I think that's a standard backtracking question. And if I can see in the topics also, yeah, hash table is obviously used here. So backtracking and how we gonna use backtracking here is simple that uh, we will start from the very first. We will iterate this basically hash table or vector which we have taken to store the frequencies of the characters in the tiles. So we will start from 0 to 26. We will run the loop, okay, one by one. And what we can do is we can also like sort this after add this to their map. It doesn't matter anyways. Okay, so 0 26 we will run the loop, and firstly we will add a to the answer and add 1 for every time we run this function. This is basically a recursive function. Every time we will add 1 to the answer and plus we will call the recursive function. Okay, answer will be incremented 1 every time because we get a new combination every time. So initially it's only A, then we will again get a this is the second, and again we will get a B. Once the number of tiles is finished, we have reached, then we will backtrack. Okay, now we'll backtrack it and we will see now instead of A we will have a B here. Fine, and then the remaining A here. Perfect. Now backtrack to whole last and then start with B itself. Earlier we started with A, now we'll start with B. B A, then B A A, and how many of them are here? And then we'll backtrack again and we'll only okay we will have a B here also, then B A, then B A. Okay, so how many are there? 1 2 3 4 5 6 7 8 must be the answer for this. And yeah, perfect. Perfect. Fine. So this is how we can do this. And now we need to see like how we can do it is, let's take a frequency vector, frequency int. Frequency and 26, initially 0 is the frequency, and for character of the tile of tiles we can see frequency of tile plus plus we have stored the frequency. Now we will just return the solve function with this frequency vector inside it. Let's int and solve and vector int and frequency. And what we will do here is, let's take an answer. We'll run the for loop from int I0 to I less than 26 because there are this much characters only. Okay, and each time we'll do what? If we do not have that character in our frequency map, like if frequency of I is 0, then we will just continue. But if there is something, then we will call it answer will be 1 plus solve the function again for frequency, but yeah, we will decrease the frequency of that element by 1. Maybe they are multiple, like in the example we took a, and then after this function call, what we do is simple. Every time we backtrack. Backtracking is what we did earlier before that function call, just reciprocate them, means just the opposite of it. Frequency minus minus we did, we'll do frequency plus plus, and we'll return the total here. Rest of the work recursion will handle. We don't have to worry about that. Anyways, we see how will the recursion work, and that's it. That's a pretty easy question. uh oh, not all, that was answer. Frequency of tile plus plus tile. Okay, it is a tile is a character. Okay, 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 it's a character, so converting it to integer. Yeah, I forgot that. Not actually this, actually this. Yeah. Okay, still the wrong answer. Uh, 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 Tile minus a plus plus I, yes, frequency is perfectly fine. Output is 3, we expect it to be 8. Fine. Frequency 26 तक चलेंगे हम. We'll go up to 26. Each time we will check that if the frequency of that element is 0. If it is, we'll continue. Otherwise, okay. Answer is equal to answer plus 1, it should be. Or we can say answer plus is equal to 1 plus solve. Okay, because we have to add the previous answer to that answer also, right? We can't be like every time 1 plus solve only, so it will give us the wrong answer obviously. Perfect, let's submit this. Yeah, good. 1. In the same way we can do this with DFS also. Like DFS is basically the same thing as backtracking. We go to one way, approaches to the end of that way, then backtrack, or we come back up to the step where we have another branch of the graph, means another way of doing this, right? So we go a b, then we backtrack, coming to a, now coming back to a, then we go to b, then a b, and then a, right? Then we go to whole to the root, then we'll start with b. B is one of the solution, then b, a, and then again a. That's how all the solutions are like explode, and that's how it's done using the DFS. So yeah, that's pretty much. So that's it for this question, easy one.